Okay, welcome in everybody. I wanted to go over some concepts and show you how to move around some homework and StatCrunch a little bit so that you could progress in this chapter. So first I want to cover some important things going on in the book, which hopefully you are going through and reading the e-text, the ebook, and making sense of it and using that to work on your homework, right? The videos are really important, but also reading through this can be really, really helpful and give you some information that isn't just in the videos. So we're transitioning now to inferential statistics. That's from the descriptive statistics. So I mentioned this before. Descriptive statistics are largely just you're giving a description to your data. Here's the mean. Here's the standard deviation. Some things that you can just talk about, and they're helpful to know about your statistics, but they don't really help you make really powerful statements. And that's what the inferential statistics does, is it gives us stronger, more powerful tools to be able to make stronger statements about the data sets that we're looking at. And so that's what we're looking at here. So one of the first things we want to realize is what we've been dealing with so far are what are called point estimates. So point estimates are single values that give us a measurement on the data sets that we're looking at. So one of the important differences between the sets we're going to be looking at from here on out are the difference between proportions and the differences between means. So you're going to want to think about that and get used to those definitions. Proportions are generally when we talk about a percentage of a population having a certain characteristic. Means are when you're taking a bunch of numerical measurement that you could take the mean of. Right? So for instance, we could look at the proportion of students at Ventura College who prefer online classes. Wouldn't make sense for that to be a mean, right? That's the proportion. We can think of that as what is the percentage of students at VC who prefer an online class. If we were to take the number of units that everyone is taking at Ventura College and look at that data set, we could look at the mean of that. Right? So you always want to ask yourself, because most of the stuff we do from here on out, you need to ask yourself, is my data a proportion or is it a mean? And your homework for this section, this chapter, is also going to have questions like that, where they give you something and you have to decide, is this a proportion or is it a mean? Because we deal with things differently. So we can have a point estimate for a proportion and for a mean, and your point estimate is basically going to be whatever you measured in your data. So if you go out and you ask 100 Ventura College students if they prefer online classes and 47 of them say yes, then that tells you that 47 out of 100, or 47%, prefer online classes, and we generally would say that the proportion is 0.47. It's just the percentage written as in decimal form, okay? So point estimates are great, but they're generally wrong, because think about it this way. If I sent everyone in the class out to ask 100 students if they prefer online classes, you're not all going to come back with the same number, right? Let's just pretend that make it up and say it's around 47% of people prefer online classes. One of you might come back with 47 out of 100 students saying they prefer online classes. Someone might come back measuring 49 students out of 100. Someone might get 45 students out of 100. Someone might get 53 out of 100. Everyone's going to get, a slightly different proportion that falls somewhere in the neighborhood of the actual proportion, which we don't really get to know, right? So when you measure a point estimate, you're almost always going to be wrong, right? Because like we said, if I send all of you out to do the same survey, you're all going to come back with slightly different numbers, which means almost everyone, and maybe everyone, will actually be wrong in their measurement. That's why a point estimate is tricky. So what we try to do, one of the things we're going to do in this chapter is create what's called an interval, a confidence interval. And what it means is instead of having a single value that we measure, we're actually measuring an interval over which we say, we think the proportion is in here somewhere. So instead of going out and measuring 47 out of 100 students saying that they prefer online classes, and we could just come back and say, well, there it is, 47% of students prefer online classes, we might say, we think that the true proportion of students who prefer online classes is somewhere between 0.45 and 0.49. In other words, between 45 and 49%. That makes us more likely to be true because we're giving an interval instead of just one number and hoping that one number is perfectly right. Okay, so that's one of the big things you're going to be looking at in this chapter is creating an interval that we can have a certain level of confidence in. You can create a 90% confidence interval, 95% confidence interval, 99% confidence interval. In fact, you can do any percentage you want, but those are the three most common, are 90, 95, and 99. So we're going to be looking at those. So you'll have questions in the homework and throughout the Canvas assignments that look at the difference between a point estimate and an interval. So you can see 5.2 says confidence intervals for a proportion. So again, it's a different if we're determining the confidence interval for a proportion versus the confidence interval for a mean. Okay, so they kind of give a little description in here. They liken a confidence interval is like a fishing net, whereas a point estimate is like having a spear in a murky lake. You're just stabbing into the water and hoping you're going to hit a fish rather than being able to throw a big net, right? The interval is like the net and the point estimate is like the spear. If you're throwing a spear, you're going to miss a lot. If you're throwing a net, you're usually going to get, you hope to be able to get something, right? So they kind of talk about that in here, capturing the population parameter. So let's talk about a 95% confidence interval. The 95% confidence interval is the most common one, but you'll see that you'll use 99, you'll use 90% confidence intervals, and in the videos that you'll be watching, there's much more details. I'm just giving you a quick overview here and then kind of pointing out some things that I think are important. This number 1.96, you're going to see it come up a lot. That's because that's the number of standard deviations, right? So you can think of this in terms of a z-score. Within 1.96 standard deviations of the mean is 95% of your data, right? So we want to be, in this case, we call it 95% confident that the interval we create will contain the actual true population proportion. We don't ever get to know what that true population proportion is. We go out and measure it, and we just are confident. We can be 95% confident if we do things carefully that the true population proportion is within our interval. So again, with it, instead of saying, well, we measured 47 out of 100 students prefer online classes, instead of saying, well, there it is, it's 47%, we might say, well, we think it's from 45 to 49%. That gives us a little bit of wiggle room to say, well, we're pretty confident that it's in this interval somewhere. Okay, so that's what we have. The point estimate is your p-hat. That's the proportion that you measured in your sample. That for my hypothetical situation, that would be the 47 out of 100 students. This 1.96 is the number that you'll use for 95% confidence intervals. That number is a little different if you do a 90% confidence interval, and it's different if you do a 99, but you'll start noticing that number 1.96 come up. And then we have this thing called the standard error, which is the square root of p times 1 minus p over n. So basically what you do, you take the standard error, you multiply it by 1.96, and that gives you how far you're going to go up from your p-hat and how far you're going to go down, and it creates an interval. So this is a picture of what a 95% confidence interval means. It means basically 95% is 19 out of 20, right? So if I send 20 of you out to go run a survey and create a confidence interval, 19 of you will have an interval that contains the true proportion, and 1 of you will miss. Right here, this red one is missing. 5% of the time you miss, 95% of the time you're correct. Your interval does contain that true value. That's what we mean by the percentage of confidence that you have. Okay, so they've got the 95% confidence interval for parameter. You see that 1.96. It's telling you how to construct the thing. So we can construct them by hand. So you see, let's look at this example. So in section 5.1, we learned about a Pew Research poll where 88.7% of a random sample of 1,000 American adults supported expanding the role of solar power. Compute and interpret a 95% confidence interval for the population proportion. Okay, so in this case, the standard error is going to be 0.010. To compute the 95% confidence interval, we plug the point estimate p hat. So that's this number out in front. That's the proportion that we measured, right? 0.887. That's 88.7% written as a decimal. So that goes in front. That's our p hat. Plus or minus. So to get an interval, we add a value and we subtract a value, the same value, and that's going to give us our interval. So what we're adding and subtracting is 1.96 times the standard error that we saw that formula for just a moment ago. And then that gives us the interval. So you can calculate these things by hand, and you sometimes will want to do that. But oftentimes we also want to use software in order to do that for us. So let's see what this would look like in StatCrunch. So you have to always ask yourself, am I calculating a proportion or a mean? Well, this section's on proportions, but also since we're talking about a percentage of people, then we know we're talking about a proportion. So you go to stat, you go down to proportion stats, one sample, and we want to do with summary because we don't have the raw data. We just have with a summary. Now notice you're going to see two things here. One, this says hypothesis test for P. That's coming up. So in a few chapters, when you have to do a confidence or a hypothesis test, you know where to come look, right? But we're interested in a confidence interval. So I'm going to click this. We want it to be a 95% confidence interval. If you wanted it to be 90, you'd change there. If you wanted it to be a 99% confidence interval, you'd make it like that. But we're just going to leave it as 95, which is kind of a standard. If you don't know what level to make your confidence interval, you make it a 95% confidence interval. You can change it if you have good reasons, but that's kind of the default most of the time. Okay, now what about this? Number of successes and number of observations. Well, that's a problem because that wasn't given in our problem. Right, let's see if I can move this up here. They didn't tell us the number of successes. They did tell us the number of observations. They said it's out of 1,000. So 1,000 observations. But how do I know the number of successes? Well, they gave us a percent. So if I multiply that percent times the number of observations, it's going to give me the number of successes. So 88.7% of 1,000 is 887, right? So you can work backwards sometimes if they don't give you the information in the way that you need it. You get it. You just calculate it. So now I'm going to hit, let me make this smaller so you can see. I'm going to hit compute, and it gives me this. You can see it gives me a standard error, right? It's giving me the count, the total. But here's the important part, the lower limit and the upper limit. That's the lower limit of our interval and the upper limit of our interval. And those numbers should look familiar if we put them here. Let's see if I move this up. The lower limit of the interval in the book here, 0.8674. Notice if we round our lower limit, that's what we get. And 0.9066 over here, that's what we get. So we have reproduced this using StatCrunch. So using the book, you can go through and figure out how to calculate them by hand, which you will want to probably do a couple times on the homework. But also, we can use StatCrunch to do it for the homework. And also, we can use StatCrunch to do it for the project, which we will definitely want to do. Now, in mathematics and statistics, we should never use a computer to calculate something that we don't understand. So don't just rely on StatCrunch to calculate these for you without understanding what you're doing, right? There will be times when you can do a homework problem or something, and you say, oh, I just had StatCrunch calculate it for me. But if you're doing that and you don't understand what you're actually doing, you're cheating yourself out of learning the topic that you're supposed to be learning, but also it's going to hurt you down the road when all of a sudden that missed knowledge that you have starts to add up, and then all of a sudden you can't do anything in the course and you can't move forward because you've skipped over all this knowledge that you needed to learn. So please take the time to understand what's in the book and how to calculate these confidence intervals by hand. But in the reality, once people understand confidence intervals, we oftentimes use software to calculate them for us. Okay. Let's look at another problem. Okay, let's look at some homework problems. So let's go into the homework here, do the teacher preview, and let's look at a couple of these problems. So we've got, for each of the situations, state whether the parameter of interest is a mean or a proportion. So you just want to think about it. In a survey, 100 college students are asked how many hours per week they spend on the internet. Okay, so think about the answers they would be giving. They're going to be given numbers in terms of how many hours per week they spend. So is that a percentage of students that are doing a thing, or is that going to be something we could take the mean of? Well, if 100 college students tell us how many hours per week they spend on the internet, we could take the mean of that, right? So the answer should be the mean. In a survey, 100 students are asked, what percentage of time do you spend on the internet? What percentage of the time you spend on the internet is part of your coursework? So again, would that be a proportion? It's a percentage, but everyone's giving us a different percentage. So this is going to be a mean. This is something we could take the mean of, right? A proportion usually comes from you ask people if they have a certain characteristic or not. Do you believe this? Yes or no? Do you agree with this? Yes or no? Do you prefer online classes? Yes or no? And then you have a very clear percentage of people that support that thing or don't, or believe it or don't. So in a survey, 100 college students are asked whether or not they cited information from Wikipedia in their papers. So we could then, once we have this information, we could calculate what percentage of students cite Wikipedia in their papers. So that's a proportion, right? Proportion there. In a survey, 100 college students are asked what percentage of their total weekly spending is on alcoholic beverages. That's something we could take the mean of, so that's a mean. In a sample of 100 recent college graduates, it is found that 80% expect to get a job within 1 year of their graduation date. That is a proportion. That is a percentage of students having a certain characteristic proportion. Okay, so you're going to have to go through and you're going to think about that a lot in the next few chapters. Am I dealing with a proportion or a mean? That's oftentimes going to be step one. Okay, then let's look at problem number 5. Okay, problem number 5. A store randomly samples 603 shoppers over the course of a year and finds that 142 of them made their visit because of a coupon they received in the mail. Construct a 95% confidence interval for the fraction of all shoppers during the year whose visit was because of a coupon they'd received in the mail. Okay, so what we want to do is you could go back. You want to go back, read these few pages about confidence intervals for a proportion, and right here we see how we conduct a 95% confidence interval. So you can go through and you can do that. Okay. Oops. But I want to show you how to use StatCrunch to do it. But again, it's always right here in the book if you need to do this by hand at some point. Sometimes you're actually better off doing something by hand here. So we go into StatCrunch. We're doing a proportion, one sample with summary. So let's see, what was the problem here? It was okay, so they're telling us 603 observations because 603 shoppers. Oh, and in statistics, when we say the number of successes, that just means you've counted the thing that you're counting. It doesn't mean good or bad. It just means we were looking in this problem for the number of people who made their visit because of a coupon. So that's 142 successes. So 142. We are doing a 95% confidence interval, right? That's what they told us to do. construct a 95% confidence interval. So we're going to do that. Let's move this kind of over to the side. And if we look at the values, we see that those line up with what we got here from StatCrunch, right? 0.2016 and 0.2693. When we round that 3 up to 4, it becomes this number right here. So StatCrunch is able to go through and calculate those for us in the way that we want. Okay, for problem number 6, write the null and alternative hypothesis in words and then in symbols for each of the following situations. So you have to figure out which one is right. So a tutoring company would like to understand if most students tend to improve their grades or not after they use their services. They sample 200 of the students who used their service in the past year and ask them if their grades have improved or declined from the previous year. So in symbols, the hypothesis test looks like this. We have H sub 0 means the null hypothesis. H sub A is the alternative hypothesis. If you're trying to prove something with a hypothesis test, what you're hoping to do is reject the null hypothesis, and that leaves you with strong evidence for the alternative hypothesis. So in this case, a tutoring company would like to understand if students tend to improve their grades or not. So improving their grades, we want, what is our P? First of all, we know we're dealing with a proportion because it's P in here, right? We use P when it's proportion. And by most, what does it mean if we say most students? So most students generally is going to mean more than half. Right? So in other words, a majority, like we looked at before. So a majority means more than 0.5 of a proportion. So it looks like it would be this one right here, right? Because the sort of null hypothesis would be that P is equal to 0.5. And when we reject that, we want to be able to say that P is greater than 0.5. And so we see that answer right there. Okay, so that's the kind of logic that you're going to go through in order to set these up. These numbers here don't make sense as proportions, right? Not for our problem. Now this one is for a mean. Notice how they're using mu. So mu tells you that we're dealing with a problem that's a mean. I haven't even read this problem yet, but I already know it's about a mean. Okay, so you're going to play the same game, except now you're going to be thinking about in terms of means instead of proportions. Okay, so let's look at this problem. It is believed that nearsightedness affects about 8% of all children. In a random sample of 194 children, 21 are nearsighted. So let's pull in StatCrunch and see what we can do with that. So I'm going to pull this in. Let's see. So that's a proportion. We know because we're seeing P here in the answers, but you know, in real life we wouldn't have those. But we would know we're doing a proportion because we're talking about some percent, in this case about 8% of all children. So we want to go grab our proportion stats, one sample with summary. It's going to give us this. They told us we have 21 successes out of 194 observations. We want to construct our hypothesis test is going to be, in this case, let's see. So in this case, we want to know if the data provide evidence that the 8% value is inaccurate. Well, inaccurate means it could be higher or lower, basically that it's not equal to. So it's going to be this choice right here. It's going to be the top one. So we're choosing not equal to, right? You have to look at the wording of the problem and decide, is this a not equal to, a less than, or a greater problem? Okay. So what proportion of children in this sample are nearsighted? Okay, so we'll match our hypothesis over here with the one that we calculated over here that we talked about it. You have to remember to change this value and then pick the right symbol there. We want a 95% confidence interval. Going to hit compute. And then notice that we get the answers from over here. So this 0.1082, that's our value here. If we look at the z statistic, 1.45, that's what we have right here for the z-stat. So it's showing us that value. Or you can calculate it by hand like that's in the book. And then notice that they're giving us here the p-value, which we got right here. Here's our p-value. Okay, so you can use StatCrunch to do a lot of this calculating for us, but you want to really focus on the thinking through the problem, making sense of it.